uh, share that if you are looking for any consulting assignments or training programs on supply chain analytics or on the data visualization, you can connect with us on our email ID, which is visible on the screen. So it's krishnaidu@mathmal.com. You can also contact us on our WhatsApp number, which is 8977 And this is what the details I'm trying to show over here, and you can connect with us for any consulting and training programs. So now, without wasting time, I will take you to the Power BI some of the Power BI projects. So let me, what I'm sharing over here is the Power BI service page, and here we have done some projects. So these are the projects over here. So I will take you through one of the inventory project. Then I'll take you to the fleet management project. So you can look at both the projects today, and based upon that, you can frame your own projects for your company. See, this is actually we derive the projects, and we derive the outputs for clients based upon their requirements and the nature of their mindset. This is a simple inventory, the Power BI project, where we have built some data visualization using analytics and the KPIs, building KPIs for the client. But this I want to make it very clear that this visualizations, this the objectives of these particular visualizations, they will change based upon the mindset and the requirements of the team and the clients. Right. So our client wanted to actually understand the closing balance, right? Closing balance by location. So what is the current closing balance? We want to understand, and what is the percentage of this closing balance or the current inventory is there across the different locations. If you look at the quantity by locations, this is the percentage of different inventory at different locations. And if you look at the highest inventory is at the location called that is 31% over here. This is actually the FSR. This one, the highest inventory is actually based in the FSR location. So here the KRT is the central location. The KRT is actually holding only 16% of the inventory, and but one of the spoke in the hub and spoke model, the spoke is actually holding a lot of inventory. This is one of the alarming situations. Maybe this could be alarming. Maybe this could be good because this location might be having a lot of sales. So that we might be holding a lot of inventory, or maybe the sales are about to happen, and they have actually brought the inventory to the location, to the warehouse, and about to happen. But also another scenario. Third, maybe the sales are not happening. Sales are not happening. There is a third scenario. So, but one thing is that the central location the KRT, the central location is the hub, is only holding 16% of the inventory. So this is what this needs to be. Maybe they are short of inventory. Maybe they are about. They have put the inventory on order, or maybe they just know they have released the inventory to some other location. So that may be the reasons over here. The central location has the lowest, one of the lowest inventory here, and the FSR has the highest inventory. So we have to understand why the central location has the lowest inventory, and why the spoke location is having the highest inventory. So if you look at here, one more location that is called GNA. The GNA is NYL. NYL is holding 20%, 24% of the inventory. Right? So is this the month end scenario? Because the month end scenario, we will be holding a lot of inventory and we will be looking to sell them. Right? So this is also one of the things we have to look at over here. Based upon that, we have to understand why our spoke locations have high inventory to the central location, or maybe the central location and the spoke locations are very far from each other, so that the lead time to supply from central location to the spoke locations is very high. That's why the spoke locations are holding higher inventory. Right? So we need to understand why the central location has lower inventory and why the spoke locations have the higher inventory. Maybe the management is strategizing to keep lower inventory at central locations and higher inventory at the spoke locations, because they don't want to have frequent transportations between the central location and the spoke location. So they want to save this transportation cost So that is the reason why we're actually holding all the inventory here. Maybe there's some stock is instead of going to central location, is going towards the spoke location from suppliers directly. So they want to save some of the transportation costs, you know, or the transshipment storage point, storage costs, right? That is also maybe one of the locations. So we need to understand why this particular. I say, if my client is there, and he will be able to understand this situation much better because he understands the scenario much better than us. Because we are just speculating here. What are the possible scenarios of having high inventory at the spoke location and the low inventory at the hub locations? Same thing we are doing at the bottom by value. This is by the top one. The top two slides are by the distribution by the quantity, and the bottom two slides or the visuals are by the value. Right? The same thing what we are doing. And if you look at here, we have a KPI here. Right? So if you want to know what is the inventory of this particular part number, let's do one thing. So this, let me select all. So this particular part, that is having an inventory of 5 units here, right? 5 units in, and that is also in the KRT location. So this is a slider, so we can actually select various parts and check their current closing balance. Right. So like this, we can check the suppose this is a part 8000 and this is having inventory closing on current balance at 3 locations, and KRT is having 118 location, 18 units. FSR means other location is 2 units. OB is another location having 2 units. Right. So this is 82% of the inventory is in the central location. That's the hub. So like this, we can actually select different parts and visualize the availability of the inventory at different locations. Look at here, the stock value is 765 units. Total units are 4, and this 4 is distributed across NYL 2 units, FSR 1, GNA 1. Right? 50% of the stock is in the NYL. So this will be very helpful. Suppose if you do a transfer, you want to suppose there is we have a requirement at one of the location, but that location is not having the inventory. So in that case, we can actually decide to do some kind of transfer from one of these 3 locations to a particular location based upon the lowest distance between them between the location which doesn't have the inventory, and plus we look at the location which has the highest inventory. Right? We can actually, based upon those things, we can actually decide which location should be able to transfer to the other location. Right? This is very helpful when doing analysis. And this is by part number. This is by part description. If we don't know the part number, then we can actually use the part description to actually find the volume and the value. Right? So this is what the client is actually is using this particular DI, the data visualization, and he is able to make decisions while in the sales and operation planning meeting, as well as when, when he wants to analyze and make some useful decisions. Now I'll take you to the reorder report. See, reorder report is something what we have 4 metrics over here. That's what is how much reorder we have to do in the next 6 months. What are the issues per week? What is days of inventory? And what is the current stock? And below we have a table here, and this table is going to give us understanding about the part number and the part description, and what is the reorder we have to do in the next 6 months. What is the current days of inventory we have? What is the stock on order? How much we have placed an order? What is the current stock, and what is the issues per week we are doing? So this is also very useful because this particular visualization is a combination of the slices and the table. Suppose you want to select one of the part here, right? So this part has no inventory over here right now. Now suppose let me also explain you what about these slices. This is ABC, and this is going to be like this particular ABC is being derived based upon the 80-20 rule. And this is XYZ. This is derived based on the variability, how much variable the demand is. Right? Suppose you want to understand the A items. Sorry, this is coming B and C. Let me click on screen. These are list of all the A items, right? So this is what we need to put the highest focus on because they are the items which have the highest demand. Highest demand, or probably on base of the frequency, we cannot say that we have to do some frequency analysis in a separate way. But what we can say is these are the items which are have the highest requirement. So maybe this way we can also define these items as the critical items. So if you look at here, the first item part number, control arm, filter cap, filter cartridge, local washer. They are having the total demand of, we have to reorder of 14 units in the next 6 months. So what our client wants to do is that he don't want to order in parts. He want to plan the ordering for next 6 months. So he will be ordering 192 units of this almost 3, 4, 5, 6, 7, 8, 9 parts. Right. So this will be ordering almost this 9 parts, and he will be ordering 190 units cumulatively. And we have the reorder value, reorder volumes for each of these part numbers separately also. So he is going to order this number of units for the next 6 months for the A class items, means which are having the highest requirement, right? So this is if you look at here, currently we don't have inventory in the warehouse. Only one of the item has the inventory for 18 days of consumption, and the current stock is like 1 unit here, right? And this will be useful for only 18 days. And issues per week is 1.36. This is what the current. So the total issues are 7.9 units. Current stock is only 1 unit. Stock on order is nothing. Zero stock on order. 18 units, 18 days of stock we have, and the total reorder he has to do for the next 6 months is 192 units. Now, if I want to do the same thing for, want to combine the least variability and highest volume. So these are the items, these are most predictable in nature because they have the least variability, right? Out of A items, now what I'm doing within A, how many items are actually how many items belongs to X units, X group, or X category. X category means the least variable category. Now these are the items 1, 2, 3, 4. These 4 items are actually belongs to the A group, and the least variable means for this item, if you do any kind of predictions or reordering, so they will be having the least likelihood of overstock and understock. So these are highly predictable. Means if we do predictions for these items, the likelihood of getting overstock and understock will be very less. Now if I remove this X and go to Y, right? These are the A and Y. Means these are the items which belong to the high volume but having medium variability. So the likelihood of getting overstock and understock is neither too high or neither too low. Now, if I want to unselect this Y and select this Z, right? And these are the items. This is no Z means highly variable. So we don't have any item which belongs to highly variable items, right? Same thing. I remove this A from here and select B, and I go to X, right? These are the items which are neither high volume nor low volume, but having mid volume and highly predictable. Means the likelihood of getting overstock and understock is very less. So these are the items we can actually have some kind of peace with, because the most the troubling things in the inventory management or forecasting is the negative outcomes, which are the overstock and the understock. So if you follow this, if you know this list of items, right, which are having very least or very mid range of the variability, or sorry, low range of variability, but actually they are belongs to group B group of items, which are either too high volume or too low volume, right? So we can actually have a consistent tie-up with our suppliers, right? Where we have the trust that they have the least variability. We can have a good contract with supplier and we can manage this particular items with ease. Now, if I unselect this X and go to the Y, these are the mid-range variability. There are only two items. And then we go to Z, there is no items over here. Good. I think we're just very happy that we don't have any Z group of items. Now C and X. This again, C group of items with very least amount of demand. Demand is very less, but whatever we can do the prediction. Means the likelihood of getting overstock and understock is very less. We can look at this number 662, 1946, issue per week, 66 days of inventory we have. And the 66 of inventory is coming with how many items? It's the 119, other is 19, so 38, and the other one is 6, 44, and the one more 22. So I think there are four items which are actually having which are having days of inventory, but rest of the items are not having any days of inventory. Means we need to plan such all those items. At least we have these four items. We have some inventory to go with. So if you look at the situation in supply chain is very bad right now. So a lot of work has to be done to actually improve supply chain based upon this particular visualization. So if you have the right visualization, you can actually track your things faster and act on those things faster. So that's why visualizations are prepared. So to know what is happening wrong and act on those things so that we things stop bad things happening for from there on, and having resolutions done properly. That is an objective data visualization, and we are able to do this. Now, if I go to location and I want to just do the analysis by location-wise analysis, so let me go to first KRT. KRT is my central location, means the hub. So here we have the total units of reorder is 63 units. We have 2.61 issues per week. 26 days of inventory we have, and current stock is only 2 units. Means only two of the one or two products have the. There's only one product have the some of the closing balance over here. There's break lining. Right. We have to order 14 days, and this is going to be sufficient for 26 days. Right. So now what we have to do is we have to plan the reorder, and we have to get the order and supply, and there is 40 units for the next 6 months. So this is for the KRT location. Same thing I will do with the GNA location, right? 247 units. Same thing I will do NYL location, it is 200 units. Now I'll check with the OBD units, right? OBD location. So we can actually get the understanding about the location-wise requirements. Same thing if you want to do with the parts, you can do by parts also. So this is helping our client to improve the supply chain because they're able to understand what is. So this is to understand what is the issues per week by location, reorder by month, how much we have to do reorders by month. So January month was the heaviest load, which they have already done it. This is by location. This is by issues by. Now here what we're trying to do is that we are trying to understand the percentage of XYZ and ABC by location, XYZ location, and how much we have, the combination of AZ, AX, Y, AX. A is our ABC is our volume-based analysis, that's based on Pareto. XYZ is our variability analysis based upon the COV, coefficient of variation. So we are trying to build this matrix and trying to understand how many items are there by by location, like for X, how many items are there. So if you look at, it's a very good scenario, 72.62% is a very good scenario, means we have 72% of items with X in FSR. So which particular location has the least 34.39%? That's KRT. KRT has the least number of X group of items, means the variability point of view. So there is a KRT has the least number of less variable items. So we have to work on this kind of things by knowing it. So if you look at here, out of ABC, if you look at here, orange is 8, that is 60% almost. B is 23.78% current stocks by ABC. And last we'll go to the lead time and fill rate, and here we have done some analysis of spend analysis. Not spend analysis, we have done the lead time analysis. So there is a local supplier, international supplier. So local supplier, what is the lead time? So international, what is the lead time? Right. So now we have two suppliers that is both having a lead time of 1 minute from this. So you can do analysis by A, B, C. Let us select all suppliers, right? So all suppliers, and we are doing a study of only A items. So for A items, we have different kind of suppliers over here. What is the lead time? So we need to understand that which if you want to make a supplier selection, you can make a selection based on the lead time. So then this is one of the report which I wanted to show you, and then I will move to the second report. And this is a fleet management BI. This recently we have built. So here we have locations, we have your fuel type, here we have month filters, and here we have mileage by location. So there are some trucks which are being operated at these locations. So what is the mileage we're getting over here? So mileage is 1.47. The trucks being which are operated in NY here, getting a mileage of 1.22. Trucks are operated from KRT to 1.47. So the highest mileage we're getting is 1.47, which are OBD and KRT. The trucks being which are having the calling point at KRD and OBD, and they're having higher mileage, but still 1.7, 1.47 is very less. We look at the total distance which trucks have traveled in a one financial year is 2.21 kilometers, 2.21 million kilometers, right? And the total fuel is issued is 1.34 million. And the mileage is the distance divided by the fuel consumption, that is 1.65, right? And similarly, is what is the average amount of fuel consumed per day? That is 533 liters. And what is the maximum amount of fuel consumed per day per transaction is 1478. Right? So if you look at trucks which are traveling, the highest is from the OBD. The fuel issued by location, the maximum fuel issued is also issued at the OBD because they are traveling the maximum distance. And this is what we have truck-wise mileages. Like TN200, this is a truck number, and this is having a mileage of 3.46. Second truck TRM 296, this is having a mileage of 3.44, right, 2.07. So these are all the trucks we have, and these trucks are this particular graph is arranged in the decreasing order. So the best trucks will be visible. Best truck with the best mileage means the truck with the best mileage will be in the beginning itself. So we can actually see the worst trucks will be at the ending. Right? So worst truck is if it is 0.54 is the mileage. This T1217, T166. So we need to work on these trucks so we will improve their mileage and reduce our transportation costs or fuel costs, fuel consumption. Right, so again, we have the asset distance, how much distance the truck is traveling. So of course, this is around 177 is traveling the maximum distance. Then 205. Right. So this is what we have over here. Let me show you the fleet profile. So this is the aging of the trucks, right? What is the current? How many years the truck is under operation? If you look at the average aging is 12 years. The average aging is 12 years, median age is 13 years, maximum age is 18 years. So the fleet size which the client has, the maximum age of the truck is 18. Average age is 12.06 and median age is 13. And here we have a different kind of body types like cargo, bulk container, tanker. And these are our model type. Now go to the availability and utilization. So average utilization is 0.45 days, and the average availability per day is 0.86 or 86%. So this 86% of time is is available, and 45 to 30% is the utilization. And if you look at here, this particular, if so 18 years, right? The size, the age of the truck, which has 18, has the highest utilization, 20.3%. Then the average age is 17, the utilization is 9.03. If you look at here, the aging, the availability is highest with the 13 aging. If the aging of fleet is 13 years, we have 93% availability. The aging is 8 years, we have 94% availability. So this is the aging wise, So means it will be helpful to know, whether the higher age trucks are being utilized more or lower age trucks being utilized. And if you look at the utilization is decreasing month over month, right? The availability is also decreasing month over month. Is it because of the corona or something else? We have. Next is the trip statistics. So how many metric tons we have carried by with truck? How many metric tons we have carried with trailers? How many tons have offloaded? This is distance factor, means what is the actual distance with respect to the standard distance, means we have exceeded the expectation. 1.02 means the actual distance is 1.02 times the standard distance which was fixed. The days factor, right? Because the actual days divided by standard deviation. So this is not a good thing because we are taking actually 3.79 days more than the standard days between the two locations. So this is actually we need to improve here. Now we're going to go cost performance. So this is by total cost by model. What is there's different models out there. So what is how much cost we are actually bearing from them? Cost metric kilometer per ton. So this is again model. So how many are operational? How many are not operational? So the operational is having the metric per ton is 0.4 thousand, 5,000, 4,289. So whatever is operational, we have 3.3 million. Whatever is not operational, we have 6.6 million cost coming from there. So these are cost parameters we are able to know. What is total trips? 11,901. What is the average number of trips per day? 104 trips. Right. What is total cost? This is total cost which we have beared. What is the average of total cost? That is 86,922. What is the metric per ton? Metric ton, sorry, not metric ton. We are actually it is cost metric per ton, that is 5,658. Average of cost metric per ton, that is 49.63. Cost metric ton per kilometer is 29.29. So the average cost per meter is 0.26. Now go to workshop productivity. So what is the how many days they are idle? 1.90. Average total is 84,6016. Total hours which we have worked, they worked is almost 4 million. 0.4 million. And this is a part cost, this is our labor cost, this is our what is the average labor cost, what is the part cost, this is the location by cost, location by how much hours the location where we are working, this is asset type wise, how many hours asset is actually being used. This idle time, day of the asset type, how much is idle, which one is idle. It is model wise idle, this location wise idle, this is model wise, the number of hours, and we have all the filters over here. And the fuel management is the last one. What is it? How much fuel we have currently by different locations. So this is ending balance. How much is consumed by different location? What is current balance? How much is received by the location? This supplier is giving the highest supply issued by month by year. So this is how much is being issued and issued by description, or description. So guys, this is something like the BI for the fleet management. And if you a lot of companies are into the into logistics, they need to have this kind of visualization so they can track every day or every week or based on the frequency of analysis. They should have this kind of recovery. And if you are looking for any kind of support from us, oh, sorry guys, I think I forgot to share my screen. Give me a second, I'll just update.